Hello everyone. Welcome to the class of Advanced Calculus and Numerical Methods 18 MAT 21. Today, I'll be discussing a topic in Module 5, Numerical Methods. And the topic name is Numerical Integration. Myself, Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bengaluru. Numerical integration. Numerical integration is the process of obtaining approximately the value of the definite integral, which is given by integral a to b y into dx or f of x into dx without actually integrating the function, but by using the value of y at some points of x equally spaced over a comma b. We are going to obtain the definite integral value over here, but we are not going to apply the actual integration. We use the value of y at some points of x which are equally spaced over a comma b. So the set of all values of x are at equidistant and they are spaced over a to b. So x values are starting from a and they are ended up at b. Note, the interval a comma b is divided into n equal parts so that there will be n plus 1 values of x, wherein the values of x are starting from x0, x1, x2, x3, etc. up to xn. The very first value x0 is denoted as a and the last value xn is denoted as b. So the interval a comma b will be divided into n equal parts. And there will be n plus 1 values of x and hence there will be n plus 1 values of y. And the n plus 1 values of y are referred as ordinates. Thus, n plus 1 ordinates corresponds to n equal divisions or strips. So a comma b, the interval will be divided into n equal divisions or strips so that there will be n plus 1 ordinates. N plus 1 set of all values of x and y. There are different rules to obtain the definite integral value. The first among them is Simpson's 1/3 rule, second one Simpson's 3/8 rule, and the third one Weddell's rule. Let us discuss one by one. Simpson's 1/3 rule is given by I is equal to, here we have denoted the definite integral a to b y dx as I. So Simpson's 1/3 rule is given by I is equal to h divided by 3 into y0 plus yn plus 4 times of y1 plus y3 etc. plus 2 times of y2 plus y4 etc. So the first term is y0 under the ordinates and the last term is yn. First term plus last term plus 4 times of multiples of, I can say, I think odd numbers, 4 times of odd suffixes plus 2 times of even suffixes. 4 into odd suffixes plus 2 into even suffixes can be easily memorized. Now Simpson's 3/8 rule is given by I is equal to 3h divided by 8 into y0 plus yn plus 3 times of y1 plus y2 plus y4 plus y5 etc. plus 2 times of y3 plus y6 etc. Now we can easily memorize this in this manner. First term plus last term has been added together under ordinates. Then we have 2 times of multiples of 3. y3, y6 are all multiples of 3. So 2 times of multiples of 3. And then 3 times of y1 plus y2 plus y4. All the remaining terms. All other remaining terms are considered under this multiple 3 times of. In that manner, we can easily memorize the formula for Simpson's 3/8 rule. We observe there is the coefficient 3/8 of h, where h is the step length given by b minus a divided by n. B is the upper limit of the definite integral, a is the lower limit, n is the number of divisions. N is the number of divisions. Then finally, Weddell's rule. Weddell's rule is given by I is equal to 3h divided by 10 into y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. The formula can be continued as well. Usually for n is equal to 6, we apply Weddel's rule. Or I can say when n is a multiple of 6, we apply Weddel's rule. So suppose n equal to 12 is being given, the formula can be continued in the same manner. So the coefficients are 1, 5, 1, 6, 1, 5, 1. Easily memorizable. And we also note the point that Simpson's 1/3 rule, in order to apply Simpson's 1/3 rule, n must be a multiple of 2. In order to apply Simpson's 3/8 rule, n must be a multiple of 3. And to apply Weddel's rule, as I mentioned, n must be a multiple of 12. So in general, we can say when n is equal to 6, all the 3 rules can be easily applied. So with all these theory, we can now step into the problems part. Problems. Firstly, evaluate integral 0 to 1 dx divided by 1 plus x square using Simpson's 1/3 rule, taking 4 equal strips. Hence, deduce an approximate value of pi. So we are given with the function 1 divided by 1 plus x square. We compare this standard integral with the form integral a to b y into dx or f of x into dx. So the function y is equal to f of x is given by 1 divided by 1 plus x square. So a value is equal to 0 and b value equal to 1. This is going to help us to obtain the step length h. We have to apply Simpson's 1/3 rule and obtain an approximate value of this definite integral by taking 4 equal strips. So number of strips n is equal to 4 or number of divisions n is equal to 4. There will be n plus 1 ordinates. We already discussed this in the theory part. For every n plus 1 ordinates, it corresponds to n equal divisions or strips. So n strips means 4 strips is given, n equal to 4. And that is the reason 4 plus 1, which is equal to 5. 5 ordinates will be there. In the table when we form, there will be 5 ordinates, 5 set of values of x and y. After we obtain a definite value of this integral using Simpson's 1/3 rule, we also have to deduce an approximate value of pi through the Simpson's 1/3 rule. So let us do the solution now. We are going to first divide the given interval, that is 0, 1 into 4 equal divisions. So first we need to divide 0, 1 into 4 equal divisions or 4 equal parts. So this gives us n is equal to 4. And this also implies that n plus 1, which is equal to 5 ordinates. 5 ordinates exists. So there will be 5 ordinates. Therefore, length of the each strip will be h, which is nothing but b minus a divided by n. So here, as I mentioned, integral always will be compared to the form integral a to b. So a equal to 0, b equal to 1. So this gives us 1 minus 0 divided by n is equal to 4. So h is equal to 0.25. You can as well retain in fraction. The choice is up to you. H is equal to 0.25. So thus the points of division are points of division. Means we have to divide x into 4 equal parts. And for that we will be in need of points of division. So the points of division are x varies from 0, starting from the lower limit in steps of 0.25, until we reach the upper limit. I repeat this, So we have x values starting from the lower limit to upper limit. See, integral limits takes for x. So x varies from 0 to 1. That is the meaning of it. So x starts from 0 to 1 means you have to start from 0 in steps of the step length h. So h is 0.25 accordingly. So add up 0 plus 0.25 is 0.25. 0.25 plus 0.25 is 0.5. 0.5 plus 0.25 is 0.75. And finally 0.75 plus 0.25 is 1. So until we reach the upper limit, we have to write down the values of x. So you observe that there are 5 different values of x. Hence, we are going to obtain 5 different values of y for the given function y is equal to 1 divided by 1 plus x square. So we need to now frame a table. Let us frame the table and tabulate all the values. So we have x values. X values just now we saw 0, 1, 2. I'm sorry, starting from 0 in steps of 0.25, no? 0.25, 0.5, 0.75, and finally 1. And we have the function y. Y is given by 1 divided by 1 plus x square. Y is equal to 1 divided by 1 plus x square is the given function. Let us find out for each value of these x values. Let us find out the y values. We shall round off all our decimal places to 4 decimals, usual consistency in numericals. And let us denote each of these y values as y0, y1, y2, y3, y4. So let us calculate this. We can make use of the calculator. 1 divided by 1 plus 0 square, 1 divided by 1 plus 0.25 whole square. Like that we can calculate for each of these. I will tabulate them and write on the values. So for x is equal to 1, for x is equal to 0, y is 1. For x equal to 0.25, y is equal to 0.9412. And then for x is equal to 0.5, we have y is equal to 0.8. For x is equal to 0.75, y is 0.64. And then for x is equal to 1, y is 0.5. So these values y0, y1, y2, y3, y4 will help us to apply Simpson's 1/3 rule for n is equal to 4 and obtain the answer through Simpson's 1/3 rule. We did not evaluate and do the direct integration. We have applied the integration through numerical procedure, numerical rules, that is Simpson's 1/3 rule. So let us now write on the formula for Simpson's 1/3 rule. And this we are writing for n is equal to 4. N is equal to 4 is given by I is equal to, I call the definite integral as I. So I is equal to integral a to b y dx. This is how the general formula is written. H divided by 3 into first term plus last term. Here the last term we have written along with notation, no? That is the reason we wrote down along with notation for y. So y0 plus y4 plus 4 times of y1 plus y3. 4 times of odd suffixes plus 2 times of even suffixes. Under even suffixes, we have only y2 now. We have already considered y4. And we observe the table, there is no y6, y8, etc. So whatever the values that we are existing, we have totally 5 ordinates. So 5 ordinates, that is why we are considering here 5 ordinates only. None of the ordinates should be repeated. None of them should be repeated. Let us substitute all the known values. So I is equal to integral 0 to 1, function y is 1 divided by 1 plus x square dx. H is nothing but 0.1. H is 0.25 divided by 3 multiplied by y0 plus y4. Y0 is 1 plus y4 is 0.5 plus 4 times of y1 plus y3. Y1 is 0.94 9412 plus y3 is 0.64 plus 2 times of y2. y2 is 0.8. With the help of a calculator, we can evaluate this, and this leads to the result integral 0 to 1 dx divided by 1 plus x square is equal to, rounding off our value to 4 decimal place, 0.7854 we are getting, 0.7854. And that's the numerical integration value using Simpson's 1/3 rule for n is equal to 4 divisions. So this is the answer for the first part of the problem. And there is another part of the problem wherein we are asked to evaluate or deduce an approximate value of pi. We need to obtain an approximate value of pi. We already know the value of pi is 3.14156, etc. So we need to now numerically obtain that through Simpson's 1/3 rule. So how do we do that is, we shall now integrate dx divided by 1 plus x square. The manual integration we are going to do it, and through that we will be able to deduce a value for pi. So to deduce an approximate value of pi, in order to deduce an approximate value of pi, let us consider integral 0 to 1 dx divided by 1 plus x square. Integration of 1 by 1 plus x square is tan inverse x. So we apply tan inverse x between the limits 0 to 1. So we have tan inverse 1 minus tan inverse 0. And tan inverse 1 is nothing but pi by 4, and tan inverse 0 value is 0. So we have integral value, integral 0 to 1 dx divided by 1 plus x square is pi by 4 in the manual work. This is equal to pi by 4. So now with this value, we shall now compare equations 1 and 2 and deduce a value for pi. Observe equation 1, left hand integral is same, dx divided by 1 plus x square, whose answer is 0.7854. So we can compare the LHS of equations 1 and 2 and equate the RHS. So from equations 1 and 2, we have pi by 4 is equal to, since the LHS are same, I am equating the RHS. So pi by 4 is equal to 0.7854, or cross multiply 4 to the other side. So pi is equal to 3.1416. So this is an approximate value of pi through Simpson's 1/3 rule. Hence the solution. Let us discuss the second problem now. Use Simpson's 3/8 rule to find integral 0 to 0.6 e power minus x square dx by taking 7 ordinates. So this is a problem application of Simpson's 3/8 rule. We need to evaluate integral 0 to 0.6 e power minus x square dx. So this definite integral is of the form integral a to b y dx. So a value equal to 0, b is equal to 0.6, function y is equal to f of x is equal to e power minus x square. And we have to take 7 ordinates. So 7 ordinates is equivalent to saying 6 equal parts. So very firstly, let us consider and talk about the same. 7 ordinates implies 6 equal parts. That is one and the same as writing n is equal to 6. So since n is equal to 6, let us divide the interval let us divide the interval 0, 0.6 into 6 equal parts. 0, 0.6 we are going to divide into 6 equal parts. So therefore, length of each strip is given by h is equal to b minus a divided by n. So b is 0.6 minus a is 0 divided by n is 6. So this gives us h is equal to 0.1. So with this value of h, let us write down the points of division. So points of division are starting from x is equal to lower limit, that is 0, in steps of 0.1, until we reach the upper limit, and the upper limit is 0.6. So observe there are 7 values of x, and hence there will be 7 values of y, that is ordinates. So that is what is being given for us, 7 ordinates. Taking into consideration 7 ordinates, we have to divide the interval 0, 0.6 into 6 equal parts. So let us frame the table and work out. So here x values are starting from 0. So 0, 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6. And the respective value of y, the function y is defined as e power minus x square. So the respective values of y are y0, y1, y2, y3, y4, y5, y6. So you can type e power minus x square in the calculator, and with the help of the calculator, we can put x is equal to 0, 0.1, 0.2, etc. up to 0.6 and find out the respective values of y rounded off to 4 decimal places. So for x is equal to 0, y is 1. For x is equal to 0.1, y is 0.900. And the next value 0.9608. 0.9139, 0.8521, 0.7788. The last value for x is equal to 0.6. We have y is equal to 0.6977. 6977. So let us now write down Simpson's 3/8 rule. Simpson's 3/8 rule. So whichever the rule is asked, accordingly we are going to work out, and that formula will be applicable. Otherwise, this table is common for all the 3 rules. For 7 ordinates, this will be the table for which you have to use Simpson's 3/8 rule here, or otherwise also if it is 1/3 rule or Weddell's rule also, we will be working out in the same manner. So the formula is given by I is equal to integral a to b y dx is equal to 3h divided by 8 multiplied by y0 plus y6 first term plus last term plus 3 times of y1, y2, y4, y5 plus 2 times of y3 only. There's multiples of 6 here, multiples of 3 here, but y6 is already considered along with the last term. So it is first term plus last term plus 2 times of multiples of 3 suffixes, 3 times of the remaining terms. So in the multiples of 3 here, only y3 will be into consideration because y6 is already used here in the beginning. So let us substitute all the known values. So I is equal to integral 0 to 0.6 e power minus x square dx is equal to 3 into h value is 0.1 divided by 8 multiplied by y0 plus y6. y0 is 1. 1 plus y6 is 0.6977 plus 3 times of y1, y2. So y1 is 0.99 plus y2 is 0.9608 plus y4 plus y5. y4 is 0.8521 plus y5. y5 is 0.7788 plus 2 times of y3. y3 is given by 0.9139. Can make use of a calculator and obtain the answer for this. So integral a to b, that is 0 to 0.6 e power minus x square dx. The answer, approximately rounding off to 4 decimal places, is 0.5351. Hence the solution for this problem through Simpson's 3/8 rule. Let us see the third problem now. Evaluate integral 0 to 1 x divided by 1 plus x square dx by Weddel's rule, taking 7 ordinates. Hence find an approximate value of log 2 to the base e. So the third problem is an application of Weddel's rule. Here the function is x divided by 1 plus x square. We need to integrate that using Weddell's rule between the limits 0 to 1. So we have to divide 0 to 1 into 6 equal parts, because 7 ordinates corresponds to 6 equal parts, and we have to divide 0, 1 into 6 equal divisions, and we need to write down the points of division. So let us see the solution now. So 7 ordinates implies 6 equal divisions. 6 equal divisions. And that is one and the same as writing n is equal to 6. Therefore, length of each strip is given by h is equal to b minus a divided by n. B is nothing but the upper limit, integral a to b y dx. So lower limit is a, upper limit is b. So 1 minus 0 divided by h is n is nothing but 6. We have h is equal to 1 divided by 6. Since it is a recurring value, let us retain h as it is instead of writing in the form of a decimal. So the points of division are starting from the lower limit, that is x is equal to 0. In steps of 1 by 6, we have to write down until upper limit, which is 1. So x is equal to 0 plus 1 by 6 is 1 by 6. 1 by 6 plus 1 by 6 is 2 by 6. 3 by 6, 4 by 6, 5 by 6, 6 by 6, which is equal to 1. Observe there are 7 values of x, hence we are going to obtain 7 values of y, which are nothing but the ordinates. So taking 7 ordinates, dividing into 6 equal divisions with h is equal to 1 by 6, we are now tabulating the values of x and y. So let us form the tabular column in the usual manner. So first we will write down x and then y. Y is given by x divided by 1 plus x square. So x values are 0, 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 6 by 6, which is 1. And the respective values of y will be denoted by y0, y1, y2, y3, y4, y5 and y6. Values of y up to 4 decimal places, I am rounding off and writing down the values here. So y values are 0. When x is 0, this will be 0 divided by 1, which is 0 itself. 0.1622, 0.3, 0.4, 0.4615, 0.4918, and the last value is 0.5. Now, it's an application of Weddel's rule for n is equal to 6. So Weddel's rule for n is equal to 6 is given by, let us write on the formula first. The formula says that I is equal to integral a to b y dx, and that is given by 3h divided by 10 multiplied by y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. It's easy to remember, starting from y0 to y6 in the order we are going to write on the formula. Coefficients will be 1, 5, 1, 6, 1, 5, 1. Now let us substitute all the known values. So this gives us integral 0 to 1 x divided by 1 plus x square dx is equal to 3 into h. H is 1 divided by 6, the whole divided by 10 multiplied by, I'm just substituting all the known values. y0 is 0 plus 5 into y1 0.1622 plus 0.3 plus 6 into 0.4 plus, of course, for all the product you can put a bracket for convenient, let's not get confused, plus y4 term as it is. Y4 is nothing but 0.4615 plus 5y5. So it is 5 into 0.4918, and the last term is 0.5. So with the help of a calculator, we can evaluate this and make a note of the answer. So we obtain integral 0 to 1 x divided by 1 plus x square dx is equal to 0.3466. That's not the end of the problem. When we observe the question, we have something else to do. We have to find an approximate value of log 2 to the base e. So whenever any deduction is being asked, we will be doing direct integration, and that is going to help us to deduce the value. Hence I have written this through Weddel's rule. Whatever the integration evaluation I have obtained, I have just called it as equation 1. Now to deduce log 2 to the base e, to deduce log 2 to the base e, let us do the direct integration. Integral 0 to 1 x divided by 1 plus x square dx, and that is equal to half of log of 1 plus x square, and this is to the base e. Obviously integral limits 0 to 1. It is half log of the denominator because when we make use of the substitution for 1 plus x square, right? Suppose we substitute 1 plus x square is equal to t, then differentiation will give us 2x dx is equal to dt, or x dx is nothing but dt divided by 2. So same thing under integration will be x dx, we have it in the numerator now. So this will be dt divided by 2, the whole divided by denominator we have taken as t, and that gives us half log t. And substituting back for t, we have half log of 1 plus x square. So that is how we have obtained directly. So obviously the rough work can be avoided. The substitution and all we can avoid. Directly we can write down the integration as half log of 1 plus x square. Now let us apply the limits, upper limit minus lower limit. So log of 1 plus 1, which is nothing but 2. Log 2 to the base e minus log 1 to the base e. But we recall the standard value, log 1 to the base e is nothing but 0. So we have the integral evaluation as integral 0 to 1 x divided by 1 plus x square dx is equal to half of log 2 to the base e. Half of log 2 to the base e. So let me call this as equation 2. So we have to now compare equations 1 and 2. Since the LHS are same, we can equate the RHS. So equations 1 and 2, LHS are same. We equate the RHS. So half log 2 to the base e is equal to 0.3466. Observe equation 1. Equation 1 answer is 0.3466. LHS was the integral value. Here also LHS is the integral value. So we are equating the RHS. So cross multiplying, we get the approximate value of log 2 to the base e by Weddel's rule, which is approximately 0.6932. 0.6932. Hence the solution for the third problem. So hope these problems are understandable. Thank you for watching.